In this video, we're just going to take a minute and do some review questions, some problems, and expand a little bit on our knowledge of this Boolean logic that we've been working on. So our first question says, is the following a conjunction or a disjunction? And before we answer that, we have to remember what is a conjunction and what is a disjunction. So a conjunction, let's use something besides blue. A conjunction is a statement. It usually is an and statement, a statement that is only true if both pieces are true, or a statement that is only true if we have two trues. And a disjunction, or an or statement, is always true unless we have two falses. Is only false if we have two falses. So let's look at the given problem and construct a truth table. We have P and Q. And we will write true, 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 false, false, true, and false, false. And it looks like if I'm working left to right, first I need to do what's inside of parentheses, P or Q. And if I do P or Q, I know that I have true, 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 false, because the only time that it's false is if I have a double false. Now I'm going to negate that. Now I'm going to do not P or Q. And to negate that, I just flip everything. This is going to be false, 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 true. Now I see that in order to do our last piece, I have to do not Q. And not Q is just the opposite of what we have in the Q spot. So in the Q spot, we have true, false, true, false. So I'm just going to change that to false, true, false, true. And lastly, we have an and statement. So this is going to be our whole answer. I'll just write answer because I'm running out of space. Is going to be, or you know what? Even better than that, sometimes if you're writing your last piece, you can just put your little, just to remind you that you're doing an and statement. I end up with a false here. I end up with a false here, and a true here. It is only true in the one spot. So in this case, we are going to have a conjunction because it is only true because we have when we have two trues, it's going to be a conjunction. Moving forward, write each compound statement below using symbolic form. For the first statement, we have if a person is a parent. So let's just say a person is a parent is our P. That person has a child can be our Q. A person is a parent, then that person is a child. And we can just write that as P implies Q. It's an if-then statement. So we have a conditional. Now in our next piece, we have a person is male, a person is a father. So let's use two other letters. Let's use R and S. So if that person is a male, R, then that person is a father. So we have R implies S. And lastly, we have if the person does not have a child, which is going to be not Q, then implies that person is not a father, not S. Not Q implies not S here. Moving on, we have our first definition. Equivalent statements are statements which are made up of the same simple statements and have the same corresponding truth values for all true-false combinations of these simple statements. Which just means if you were to make a truth table, all of the statements would have the same truth table. They mean the same thing. And we'll see what that means in a little bit. But first, an example is a double negative. This should be another tilde. Is tilde tilde P equal to P? Does the double negative cancel things out? We can pay our bills once we have incurred them. Is that the same thing as we can't not pay our bills once we have incurred them? And the answer is yes. It's the same as how a negative -5, if we go back to numbers, go back to math for a second, negative -5 is just going to be equal to 5. So a double negative does cancel out. So let's put those things together and see if we can figure out which of these statements is not equivalent. So take a minute and pause the video and see if you can figure it out on your own, and then we'll start. Which statement is not equivalent to the rest? So we have Oliver is blushing. We can say that that's P. Oliver is blushing. He is not sunburnt. So let's say Oliver is sunburnt. Can be Q. And we have PQ. We'll write our table. True, 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 false. False, true. False, false. And in our first one, we have not Q, which gives me, this is not sunburned, which gives me false, true, false, true. And our question, our A, is a conditional. It's if P, then not Q. So let's remember what this means. This is only false if we have P is true, if we have P is happening, but Q does not end up happening. That's the only time this is false. So when we have a true, false. When we have a true, true, it's true. When we have a false, false, anytime it starts, a conditional starts with a false, we immediately assume truth. So we have A done. B is Oliver is sunburned, which is Q, or blushing. So it's just Q or R. Or Q or P, sorry. Q or P. And what is Q or P? It's when either P or Q is true or both. So we have true, true, true. And in the bottom, they're both false. Q and P are both false, so we'll put F. So we already know that one of the first two is going to be wrong because they're two different answers. So now we can look at C. If Oliver is not blushing, so we need not P this time. So let's write that real quick. This is false, false, true, true. We have not P. And remember, when I'm looking for not P, I just look in P's section and write down the opposite of it. So we have, if Oliver is not blushing, then he is sunburned. So not P implies Q. And let's see when not P implies Q. So when not P is false, if it starts with a false, we immediately know that our statement is true because it's a conditional. When it starts with a true, the only time it could be false if it starts with a true and goes to false. This starts with true and goes to true, so this is going to be true. And this starts with true and goes to false, so we are going to have a false here. And we see, we had A, B, C. We see that B and C are the same, and only one is different, so we know A is going to be our answer. A is a different statement. If Oliver is blushing, then he is not sunburned. And you might notice if we didn't do truth tables, you might be able to get to the right answer, but it is a little confusing. It's a little hard to just read into the sentence and see what would be wrong. So in our next video, we'll continue learning terms and working on some of these questions and truth values.